文系な先生、ありがとうございました。続きまして、お二人目のご講演者を紹介いたします。オリバー・クレイル先生でございます。オリバー・クレイル先生は、英国のニューキャッスル大学で、生態分子考古学の博士号を取得されました。ニューキャッスル大学の研究員、それからローマ大学マリー・キュリー・フェロー、それから2007年からはヨーク大学の講師を経て、現在ヨーク大学の准教授、2011年からはこのバイオアーク所長というですね、まさに生態分子考古学を研究する施設の所長を務めておられます。本日はこの最新の方法論による極めて興味深いお話を伺えるということでございます。それではオリバー・クレイル先生、よろしくお願いいたします。
Okay, thank you to everybody. I would like to begin by special thanks to the Ishibashi Foundation, to the Tokyo National Museum, and to the Sainsbury Institute for inviting me to speak today. Okay, today I would like to show how both new excavations and the application of the latest scientific methods have advanced our understanding of a key British prehistoric site, Stonehenge. Specifically, my research interests are in food, its consumption, preparation, and dietary significance. I aim to show how new scientific techniques, particularly in molecular archaeology, are beginning to reveal new insights into the role of food in prehistory. I will conclude this lecture by showing how some of these methods are beginning to be applied to Japanese prehistory, adding further detail to the already fantastic archaeological record of this country. There has been a revolution in archaeology. Biomolecules such as DNA, protein, and lipids can be recovered from ancient skeletal tissues and artifacts to reveal new insights into the past that were just unimaginable 10 years ago. A large part of this research has focused on diet and cuisine. I wanted to begin today by giving some examples of ongoing projects in our BioArCh Centre at the University of York. Okay. So first, these are some skeletal remains found in one of the boat houses that lines the shore of the famous site of Herculaneum in southern Italy. That dates to AD 79, the date of the Vesuvian eruption, volcanic eruption. The same eruption, which you may be familiar with, that destroyed Pompeii. The remarkable finding provides a unique snapshot of a Roman population, as these people lived and died at the same time. We have been conducting analysis of their bones, chemical analysis of their bones, to reveal their diet. These show the variability in the foods that these people ate during their lives, and allowing us to make new and detailed inferences of how food was distributed in Roman society. This image is a human jaw from a monastic site in Germany called Dalheim, which dates to the medieval period. Clearly shown, adhering to the teeth, is dental calculus, that is mineralized plaque. We are able to extract DNA and proteins that are trapped within these microdeposits. These enable us to reconstruct the food, oral bacteria, and also the host tissues that are present. We are able to extract and sequence these molecules to determine the types of food that were eaten, to identify diseases that the person was suffering from, and also to look at how the host may have been genetically adapted to digest different foods. The next image you may be more familiar with, and Simon mentioned a little bit about this. This is a middle Jōmon flame pot from Japan, dating to around 5,500 years ago. Charred deposits have been found within many vessels like this, showing that they were clearly used to prepare foods. We have managed to extract degraded oils from these vessels. These analyses show that they were consistently used for processing fish. In this case, probably salmon, which, considering the ornate decoration of these vessels, may have a special significance to the people at this time. Finally, a much less ornate pot, dating to perhaps just a few centuries later to the Jōmon flame pot shown earlier, but this pot is from the United Kingdom. This fragment also contained molecular evidence for the foods that were cooked within it. Although rather ordinary in terms of its appearance, this potsherd is important because of its context. This pot was found very close to Stonehenge and was probably used to cook foods by the builders of this famous monument. Which leads me on to say something about Stonehenge. Well, what is left to say about Stonehenge? Stonehenge is the icon of British prehistory. It's one of our few prehistoric World Heritage Sites, along with Avebury. Although so much has been written about this site, from romantic novels to science fiction, and more recently to manga, there has been very little new research carried out until relatively recently. The history of the excavations is a lecture in itself, and Simon has already explained a little bit about the history. Over half the site has been excavated, beginning in the 17th century by antiquarians such as the Duke of Buckinghamshire. During this time, I think it's fair to say that the archaeology was systematically and largely destroyed. Only proper recording and reliable accounts began at the start of the 20th century, when in fact William Gowling, then in his 60s, was employed to restore the monument, as Simon has just described so nicely for us. In the 1950s, the Society of Antiquities commissioned Richard Atkinson, Stuart Piggott, and John Stone to carry out further excavations. They recovered many cremations and developed the phasing that still dominates much of what is written about Stonehenge today. So what did these excavations reveal? Essentially, Stonehenge is a henge monument. That is a circle enclosed by a ditch and bank. That's the definition of a henge monument. It has an avenue leading to it from the northeast. It was constructed in phases. The ditch and bank around 3000 BC, the Sarsen circle in the middle, and larger triathlons date to the middle of the 3rd millennium BC, with the final bluestone circle around the edge, complete towards the end of the 3rd millennium BC, around 2000 BC. So it's this period here. So the site therefore dates to the late Neolithic period in the British terminology, just before the arrival of metal in Britain, which marks the Bronze Age at around 2000 BC, and quite long after the arrival of farming in Britain at 4000 BC. So these were farming communities. Uniquely, Stonehenge is perfectly aligned with the mid-setting sun and the midsummer rising sun. Here's an image of the rising sun in midsummer, which shines through two of the great sarsen stones aligned with the avenue. Stonehenge is by no means unique. Henge monuments are found all over Britain, but are perhaps most concentrated in the southwest of the country, in an area known as Wessex. Here are some sites of the different henge monuments, and it is thought that they occupy different watersheds within this landscape. Here's some other examples of different henge monuments are found around Wessex, each one with this ditch and bank, and some of these are absolutely enormous. So, is Stonehenge just another one of these Neolithic henge monuments? Well, yes and no. Of course, the unique character of Stonehenge is its grand centrepiece, the stone circle, made up of different types of stones. Sarsen stones, regionally sourced, but also smaller blue stones. Which were probably brought from Preseli Mountains in Wales, requiring immense efforts and perhaps involving thousands of people in its construction. Although a lot of research has been carried out concerning the construction and alignment of the stones, the role and function of Stonehenge has been under-researched. British archaeologist Mike Parker-Pearson has led recent attempts to tackle this question. Mike has worked extensively in Madagascar, serving the people and their customs. When his Madagascan colleague, Ramil Sonina, visited the site and was asked about the function of Stonehenge, he answered, "What is Stonehenge? It's obvious, it was built for the ancestors." It became, drawing on parallels in Madagascan society, where there's a clear difference between stone-built funerary structures. Here's an example of one of the large funerary monuments in Madagascar. And more ephemeral domestic structures. Here are some of the houses in Madagascar which are actually destroyed when they're abandoned. It was clear to Mike, Ramil Sonina and others that Stonehenge represented a funerary monument that permanently occupied a place in the landscape. So Stonehenge, large, permanent stone structure, whereas the more temporary wooden structures are in opposition to this. It became clear to understand Stonehenge, the larger landscape needed to be considered. Stonehenge was just part of a puzzle. Others had already pointed out Stonehenge was part of a large complex, connected by the avenue. This is Stonehenge here. Connected by the avenue to the River Avon, and to other henge monuments, including Britain's largest one at Durrington Walls, which contains large timber circle constructions, and next to it, Woodhenge, with another timber circle. The idea that two monuments, a place for the dead and a place for the living, linked by the river Avon, was proposed. The river linking them perhaps representing the transformation of the dead from the world of the living to the world of the ancestors. New excavations were needed to find out more about the role of Stonehenge in the wider landscape. In 2003, the Stonehenge Riverside project was born, and over £2 million worth of research money were raised to support this new endeavour. New excavations were carried out, but also the broader landscape was intensively surveyed and photographed aerially to understand the relationship between the monuments. Here are some of the excavations actually at Stonehenge. This is some of the surveying work they did around the landscape. And they also did a lot of aerial survey using helicopters to try and understand the relationship of of Stonehenge within its wider landscape. Here is a summary of the areas excavated. So we have a lot of excavations around Stonehenge itself, here, along the avenue. A new stone circle was discovered at the end of the avenue where it intersects with the river, now called Blue Stonehenge. And many excavations also at Woodhenge and Durrington Walls, the other large hen monument in this landscape. Further excavations were recovered at the Great Cursus Monument, yeah, which is a large series of parallel ditches. At Stonehenge, a number of cremations were excavated from pits that surround the monument. These have been discovered earlier by William Hawley, Gowland's successor, but unfortunately, after excavation, the remains have been mixed up and reburied at the site. So, a team of forensic archaeologists, following re-excavation of these pits, were able to reconstruct the burials. They revealed cremated remains of around 150 to 240 individuals, making Stonehenge Britain's largest prehistoric cemetery. However, it was pointed out that this only represents a maximum of around 60 burials per century, if the longevity of the monument is considered, perhaps suggesting that the site was reserved for a small ruling dynasty or high-status individuals within Neolithic society. The absence of domestic refuse at Stonehenge, very little animal bone and very little pottery, strongly reinforces the idea that Stonehenge was a funerary monument, a place for the dead. So, if Stonehenge is a place for the dead, then could Durrington Walls, the other large henge monument in this landscape, could that be a place for the living? The huge monument of Durrington Walls measures 500 metres in diameter. It is in plan. It enclosed timber circles, and the use of wood at this monument, rather than stone, could not be in more contrast to Stonehenge. Also, the Durrington Walls Avenue is aligned with the mid-summer sunset, whereas the avenue at Stonehenge is aligned with the mid-winter sunset. Another contrast, perhaps mirroring the opposition of life and death. Remarkably, near the southeast entrance to Durrington Walls, the recent excavations have found evidence of a settlement. Several houses were excavated, their floors well preserved, with hearths in the centre. One of the houses. By extrapolation to the area around the monument, it is estimated that there may be as 1,000 houses in this region, supporting up to 4,000 inhabitants. These sensational findings represent one of the very few examples of Neolithic settlements in England. And here's a picture showing a close-up of one of the houses. Here are the post holes supporting the structure. Here's the floor, very well intact, with other features visible as well, and the central hearth area where the fire would have been. And usually the houses still had the floors and potentially the habitation deposits intact. By laser scanning the house floor, features such as the central hearth, slots for beds, food preparation areas, and other domestic furniture can be identified. Remarkably, even the knee marks left by someone tending the fire are observable in this house. The layout of the house and the proposed activity areas have been reconstructed. These are partly derived by comparisons with other stone structures preserved on the island of Orkney, off the north coast of Scotland, which date to the very same period. Geochemical work on the floor deposits confirms variation in the use of space within these domestic structures. You can see a lot of similarities between these houses in southern England and these stone structures in Scotland. Okay, so, however, life at Durrington Walls was by no means ordinary, as we may imagine when considering romantic tales of an English village. First, the houses were located next to a huge timber circle that was being used at the same time, most likely for public ceremonies. Second, intensive radiocarbon dating revealed that the houses were occupied for a very discrete period, perhaps less than 50 years, during the second half of the 25th century BC. And this, of course, coincides with the erection of the Great Sarsen Circle at Stonehenge. So most likely the builders of Stonehenge actually lived at Durrington Walls. In addition, Durrington Walls was a place of seasonal gatherings of large number of peoples for consumption and ceremony. It has often been compared with the large festivals of Britain in recent years, which draw people together from far and wide. And this is a very famous festival in Britain at Glastonbury, which gets almost 1 million visitors every year from all over the British Isles and Europe. As archaeologists, we need to think of what the remains of such a gathering would look like. Working from the debris, we wanted to establish the scale and types of activities that occurred, and also where people and artifacts came from. To address this, in 2010, we began a new phase of research called Feeding Stonehenge. The aim of this work was to work out how the Stonehenge monumental complex was provisioned, its social catchment, and also to detail the activities that were occurring. First, it became apparent that the amounts of material deposited at Durrington Walls was just incredible. Huge amounts of flint, pottery, and animal bones accumulated around the houses in rubbish middens deposits. And this here is the flint distribution. These are the houses, and these are thousands upon thousands of flints that are deposited in and around the houses in large rubbish deposits. Again, the sheer accumulation of debris suggests mass consumption, akin to large-scale feasting. In total contrast, at Stonehenge, as I said, very little animal bone and pottery was found. Pits full of pig bones and pottery were found around the houses. This is one of the pits that's been excavated. The discrete deposits were perhaps the remains of individual feasts. In some cases, large amounts of meat were likely to have been dumped into the pits, as whole joints of animals were found to be intact. So we have whole joints of animals that were deliberately placed in these pits. Analysis of the animal bone revealed it was almost entirely composed of pigs, and to a lesser extent cattle. So 90% pig. The absence of weathering patterns on the animal bones indicates they were buried very quickly and therefore consumed in a short space of time and on a very large scale, again suggestive of feasting. Analysis of the degree of wear on the animal's teeth reveals that most of the animals were slaughtered very young, the autumn or winter of their first year. The pigs and cattle were often butchered. Often the bones had burnt ends, which are consistent with roasting over an open fire. Across the site, fire pits that would likely to be used for barbecuing were found. The amount of meat at this site contrasts with the near absence of cereals and other plant processing, and also quern stones, which are used for grinding cereals. This is interesting, as human diets during this period are considered from other evidence to be rich in plant foods. If so, the amount of meat consumption at Durrington Walls must have been rather shocking for those who attended the gatherings. So what about the pottery? In total, over 10,000 sherds were found. To determine the use of pottery, we used a technique called Lipid residue analysis, and we carried it out on 350 different vessels at Durrington Walls. Lipids are fats, oils, and waxes. During cooking, food lipids will become trapped and preserved in the porous walls of ceramic vessels or within charred surface deposits. The method we use involves extracting the lipid with organic solvent and performing a method called gas chromatography mass spectrometry. This allows different lipid compounds to be separated and analysed with a mass spectrometer. So we take a sherd, extract the lipids, and separate out the different components. So these are the chemicals that are coming out of these pots. Then we use high-tech instrumentation to work out the chemical structure of these molecules. We found that over half the vessels from Durrington Walls contain lipids, despite exposure to the burial environment for over 4,000 years. Perhaps unsurprisingly, given the bone evidence, we found in all cases that the lipids were derived from degraded animal fats. We then used another approach to distinguish the types of carbon in the different lipid compounds. As different animals eating different foods metabolize these differently, variation in the isotopes of carbon develop in their tissues. These isotope differences are maintained and transferred to the lipids deposited in pots during cooking. Using isotopic criteria, we were able to distinguish 3 main types of food within the Durrington Wall pottery. Ruminant carcass fat, most likely from cattle, so beef. Dairy products, again, most likely from cattle, so milk or processed milk products. And pig carcass fats, so pork. What was interesting was that there were clear differences in the use of pots between the different features across the site. The spatial distribution of food residues within the Durrington Wall settlement was to a large extent patterned according to architecture and activities. Pots deposited in pits were used mainly to process pork. In comparison, the rubbish middens contained higher numbers of pots with ruminant products, presumably beef and cow's milk. The latter suggestive of additional activities during the summer of storage of fermented dairy products for winter feasts. In the ceremonial space of the southern circle, a much higher number of pots for dairy products were found. So clear differences between the different features across the site. Considering the use of food at Durrington Walls, distinctions between public and private, monumental and domestic, appear to be reinforced. Whereas meat was frequently associated with pots and roasted to serve large feasts that occurred around the houses, dairy products were preferentially consumed in the public and monumental spaces. Other studies have shown that dairying was already practiced in Britain from the very start of the Neolithic period. Nevertheless, the use of milk, specifically in these ceremonial spaces, is interesting, and it certainly must have had special significance to the people of Neolithic Britain, both as a nutritious resource available from living animals and perhaps as a magical product that can be transformed easily into yogurts and cheeses. Overall, the evidence for food sharing and activity zoning implies a degree of organisation that is perhaps not expected. Certainly, the evidence does not fit previous suggestions of a slave-based society in which labour for building the monuments was forced or coerced. We have ample evidence for sharing of foods across this monument. Clearly then, food was shared at the rental walls in massive ceremonial feasts. A second question is to understand how the site was provisioned. Where did the animals and artifacts come from? Geochemical analysis revealed that the pottery and flint at the site were produced from local sources. Antler, wood, and the salts and stones came from around the region. The dolerite blue stones, however, cannot be found in this part of England. As already mentioned, the nearest source is 100 miles away, hundreds of miles away, in the Preseli Mountains of South Wales, requiring a monumental effort to transport them to Stonehenge. Much has been written about this, and Mike Parker-Pearson and his team may have recently found the actual location where some of these stones were quarried. So what about the animal bones? As no juvenile animal bones were found at the rental walls, it is very unlikely, therefore, that animals consumed at the site were born and raised there. The presence of whole skeletons implies that the animals were probably brought in alive and killed at the site. But where did they come from? To find out, we used a method to provenance the animal bones, using isotopes of the element strontium. Strontium, present in the underlying geology, becomes incorporated into animal tissues, such as tooth and animal, via plants that are consumed. So strontium from the geology enters the enamel of tooth via the plants and animals that are consumed. Therefore, the ratio of strontium isotopes present in the animal artifacts reflects the local geological environment where the animal was raised, as tooth enamel is formed during the early stages of life. So this also works for humans. So if someone was born in Japan and moved to, say, Britain, southern Britain, they will have a clear signature of the volcanic signal from Japan recorded in their teeth that were developing when they were growing up in Japan. Strontium isotopes were measured in the tooth enamel of the cattle at the rental walls and compared with a geological map of Britain. As can be seen, Stonehenge lies on a chalk geology around here. The blue area on the map. But the cows had strontium isotope values consistent with other geological areas of Britain, including indicating they were raised elsewhere. So here's the chalk area. So these animals were probably born and raised on chalk geology near Stonehenge. These ones probably on limestone geology, so the green areas on the map. And these from other areas across Britain. Interestingly, these cattle must have been raised, I've got strontium isotopes that are only found in Scotland within the British Isles. It seems that these animals were transported incredible distances to Stonehenge. Therefore, Stonehenge and associated sites had an immense social catchment and probably well known all across Britain during this time. So, to conclude, the Stonehenge landscape encompassed a place for the living, in rental walls, and a place for the dead. Its function was for the ritualized celebration of life and death. People came together across Britain, perhaps seasonally. Immense amounts of resources were bought and consumed at the site. Monument building and aggregation required collection and marshalling of a wide variety of resources throughout the year and across a diverse range of landscapes. Gatherings involved whole communities who were involved in more than just monument building and ceremonial rites. Maintenance activities, food preparation, feasting, tool manufacture and pottery production were all carried out. The aggregation of groups from all over Britain clearly provided opportunities for individuals to stress both similarity and differences in social identity and material culture. Such gatherings were one of the ways in which artifact styles and technologies became spread across wide geographical regions. And, as today, just about, England, Scotland and Wales were probably united at this time. Okay, more recently, we have turned our attention to another question, the innovation and development of pottery in East Asia. We were very interested in knowing whether the methods for determining the use of pottery from Stonehenge could also be applied to Jōmon ceramics from Japan. A major challenge was that the earliest Jōmon pottery dates to long before Stonehenge. In fact, as you probably know, to the end of the last Ice Age. I wanted to conclude by mentioning our initial progress in this endeavour. This map shows the dates for the earliest pottery in Eurasia. As you may know, pottery in Japan is amongst the oldest in the world, dating to around 17,000 years ago. A hypothesis is that pottery spread from East Asia westwards across the Eurasian continent, eventually arriving in northeast Europe some 6,000 years ago. Although more dates are needed, the dates of early pottery production, including the dates for early pottery sites in western Siberia and Baikal, but the ones collected so far tend to support this hypothesis. So this map shows some of the early dates are here in the Far East, spreading across Russia through Trans-Baikal and across into Northern Europe. Interestingly, Eurasian communities that produced pottery during this time were all hunter-gatherers, unlike in Britain and other parts of Europe where pottery is associated with farming. Many Europeans still wrongly associate pottery as an invention of agriculturalists and farmers. Could we then apply lipid residue analysis to work out what these early pots were used for, and perhaps work out why pottery was innovated at this juncture in prehistory, and why the technology was evidently so successful? One interesting fact pointed out by Japanese archaeologists is that early pottery was initially produced at very low frequency, perhaps reflecting an early experimental phase in its development. Only after the Ice Age, in the warmer post-glacial period, did pottery start to become more abundant in archaeological sites. A model of initial experimentation, followed by integration and consolidation into everyday household and other social practices, and then dispersal was proposed by Peter Jordan and others. Notably, this model is common to the uptake and spread of many technologies. To address this question of use, we have carried out chemical analysis of the food crust deposited on the inside of many incipient, initial and early Jōmon potsherds. Here shows a typical deposit from the site of Awazu in Lake Biwa, remarkably preserved after 10,000 years. And hopefully you can see here the food incrustations on the inside of this ceramic vessel, which are remarkably preserved. The first thing we did was to analyse the isotopes of carbon and nitrogen in the charred food crusts. These isotopes broadly distinguish terrestrial foods from marine products. Marine products are enriched in the heavier isotope, so higher on this graph, on this scale, and also on this scale. Shown on the axis by more positive numbers. And freshwater fish are enriched on the x-axis, the y-axis, sorry, corresponding to nitrogen isotopes. If we compared the food crusts from incipient Jōmon pottery from those from Stonehenge, we can see some very, very clear differences. So these blue are incipient pots, and these are the food crusts found on the pots from Stonehenge, and you can see they're very different. We found that Jōmon pottery was consistently used for processing fish in the late glacial period. Virtually all the Jōmon pots had isotopic values in keeping with aquatic products, and were totally absent on the Stonehenge pots. We conducted further lipid residue analysis and were able to recover molecules derived from aquatic products, most likely fish, in a large number of Jōmon pots. These were the oldest ceramic vessels to preserve lipids anywhere in the world. Our new results suggest that the tradition of processing fish in pots continued at least until the early post-glacial period, despite climate warming and the establishment of new opportunities for hunting and gathering. Our results are still tentative and the subject of ongoing work, but perhaps the oldest pottery had very defined and restricted purpose in Jōmon society. Putting the Jōmon data together with hunter-gatherer pottery from other regions such as Russia, the Baltic, and even North America, an interesting but albeit preliminary picture emerges. Out of 182 hunter-gatherer pots which had lipids present, the vast majority could be reliably assigned to aquatic oils, whether this be mollusks, fish, or even aquatic mammals such as seals. In total contrast, early farmers, that is prehistoric groups dating to less than 1,000 years after the arrival of agriculture, had very little evidence for processing fish in the pottery. Instead, out of 500 pots analysed, ruminant meat and dairy products seem to be the major commodity processed by these groups. Here we must point out that most of the early farmer pots are from European sites, and very few early agricultural pots from other parts of the world have so far been analysed. Nevertheless, the way that farmers and foragers use pottery seems to be very different. Moving forward, we are interested in integrating our work with a much larger project team who are planning a more extensive programme of radiocarbon dating and residue analysis of early pottery from sites across Eurasia. The map here shows some of the areas we are working in. The overall aim is to examine the dispersal of pottery from East Asia along two major routes, northwards towards the Arctic and westwards across Russia to northern Europe. Could the spread of early ceramics through these regions have been facilitated by the availability of rich coastal and riverine resources? Did ceramics provide an attractive new way of processing these foods? Such a project can only be achieved by archaeologists and prehistorians working beyond their natural boundaries to address questions on an intercontinental scale. Finally, could these early pottery sites have been the focus for seasonal aggregation of hunter-gatherers who came together to make pots and celebrate the return of seasonal aquatic resources, or to participate in cooperative harvesting of such resources? And such a theory has recently been proposed for North American hunter-gatherers. Now, here we may draw parallels with Stonehenge. In both cases, the sites were centres that brought together disparate communities in order to maintain and reinforce social relations. And this, I would argue, still happens today. And this is Stonehenge just last summer, during the summer solstice, when huge crowds gather at the monuments to pay special tribute. Okay, so I'd like to finish by really thanking you, as the audience, but also the many collaborators we have on both these projects. And I think I have to point out that these projects are only capable by close integration with archaeologists working in the field and other specialists working in the different areas. Finally, this is an advert for the new visitor centre at Stonehenge. It is truly spectacular, and I really encourage, if you have the chance, to try and visit there. It opened last year. Thank you.